Hello everyone, through the medium of Atal Innovation Mission. This is Nishan Jain, research scholar from the Department of Polymer and Process Engineering of IIT Roorkee, going to present my work on the arsenic toxicity that has been present in the water and its decontamination. We talk about the introduction of the arsenic. Arsenic is an element that falls under the category of metalloid, and various sources of arsenic are the minerals that has extracted from the earth's crust, and some of the meat and the vegetables also contains arsenic species based on the geographical condition of the cultivation. So next, moving on to the chemistry of the arsenic species, that arsenic has been present in mostly in an organic state, and in which the arsenic 3 and arsenic 5 are the most prominent species of toxicity in the groundwater, and in which the arsenite has a more toxicity compared to the arsenic species. So moving on to the uses of the arsenic, that has been used for making alloys, semiconductor devices, pesticides, wood preservatives, herbicides, insecticides, and the additives that has been used for the vineyards, ceramics, glass making processes. And moving on to the exposure to the human beings, arsenic contaminated groundwater can affect the skin of the humans, nervous system, respiratory system, cardiovascular system, liver, kidney, bladder, immune system, endocrine system, and sometimes leads to the various kinds of cancers. So now next, moving on to the structure of the arsenic species, that inorganic arsenic species. As per the pKa value represented in the figure, arsenite is the arsenic 3 species that has a very that has been present at the neutral pH condition, in neutral state, which produces more toxicity compared to the arsenic 5 species or the arsenate species. So the post effect of the arsenic contaminated groundwater on the human beings can be reflected in the images that shows that various kinds of skin diseases has been occurred on the human beings and reported in the literature. So the removal of arsenic species has been important for the safe drinking purpose, and various technologies like adsorption, coagulation, ion exchange, phytoremediation, oxidation, advanced oxidation, membrane separation process has been developed to remove the arsenic toxicity from the groundwater. So moving on to the problem statement, that nearly 200 million people have been affected in the world for this arsenic toxicity. If we talk about the global scenario, that nearly all the countries in the world has been affected with the various levels of arsenic toxicity in the water. And if we talk about the national scenario, as per the Central Groundwater Control Board, nearly 5 states of India has been mostly affected with the arsenic species. And based on these problems, uh, various technologies have been developed, and various rights have been protected by developing an adsorbent for the removal of arsenic species. So if we talk about the solution to the problem, adsorption has been proved to be an efficient and the cost effective technology for the removal of arsenic species. And so we have developed an adsorbent by the combination of two different materials, which is a combination of manganese based materials and the iron and aluminum based materials. So, and we have also protected the adsorbent under the protection of intellectual property rights. And we have observed that nearly 22 and the 27 milligram per gram of arsenic 3 and the arsenic 5 species can be separated out from the groundwater. And if we talk about the kinetics of the removal of the arsenic species, we can be easily seen that the kinetics are very fast in both the cases, in the synthetic water as well as in the groundwater. So the rate has been intact, but the capacity has been reduced in the groundwater due to the availability of the various ions present in, but it can still perform best for the groundwater application. Apart from the total removal of arsenic species, the potential developed adsorbent has a potential to oxidize arsenic 3 species into arsenic 5 species, that is reducing the arsenic toxicity in the water and simultaneously adsorb it on its surface. And based on that, we have developed a mechanism in which the manganese has a role for the as an oxidant, and other elements plays a role for the adsorption of the arsenic species. And so moving forward to the real field application of the adsorbent, in which we have fabricated a setup for the real field application, like fixed bed column setup, to identify the real world application to. And we have observed that nearly 1.57 minute is sufficient for the adsorbent to treat nearly 15,000 bed volumes. And based on that, if we move on to the groundwater studies through this continuous column setup, and we have observed that nearly 8,000 to 10,000 liters of water can be produced by the 1 to 1.5 kg of adsorbent used in the filter system, which can extrapolated like the filter can run for 3 years, nearly 3 years, for the family of 5 members to and produce water. So these are some of the references in which we have our patented technology. We have used our patented technology, and lastly, we are acknowledging the various institutions like Ministry of Education, IIT Roorkee, SERB, and IPSL. And thank you for listening my work.